Hello everyone, welcome to my class. In our previous classes, we have already discussed about many concepts on force. Okay, so today we are going to discuss about uniform circular motion. So without wasting time, let's start the class. Students, let us now concentrate on this diagram. Suppose a particle moves in a circular path and it starts with point A. If it is linear motion, then it goes in a straight line, but it is maintaining the circular motion by going through the circular path. That means the direction of motion changes at each point of the circular path. That is why what happens when it goes from point A, it doesn't go straight, it goes in the circular path. Again, you can clearly see that when it reaches B, it should go in this path if it would have linear motion, but it changes the direction and goes to point C. Same thing happens at point C and D as well. So at each point the direction of motion changes. And from this diagram you can clearly understand that the direction of motion in circular motion is tangential. Okay, tangential. You would have learned in mathematics in chapter circle that a circle consists of infinite number of points and each point has a tangent. That means there is a line which is perpendicular to the center of the circle. As you can see, at this point it is perpendicular to the circle. Here as well it is perpendicular. Here as well it is perpendicular. Here as well it is perpendicular to the center of the circle. And each point has a tangent. That means the tangential motion means it changes towards the direction of the tangent at each point. Okay, you need to understand that. As you have already discussed that the speed, it is constant. Speed is constant in uniform circular motion. But what happens with the velocity? As the direction changes at each point of the circle, velocity also changes. That means we can say that the velocity in uniform circular motion is variable. Okay, it is not constant. Though speed is constant, as the direction changes at each point, so the velocity is also variable. Okay, from this discussion we can come to a conclusion that in an uniform circular motion the speed remains constant but the velocity is variable. Or you can say that the particle is accelerated in an uniform circular motion though the speed remains constant. We also understand that uniform linear motion, okay, it is unaccelerated and uniform circular motion is accelerated. We have already discussed that in case of uniform linear motion, the speed and direction they remain constant. That is why the velocity remains constant, so the acceleration will be 0. Okay, but in case of uniform circular motion, what happens? Velocity is variable, and velocity is variable. That's why the body accelerates with the flow of time. That's why this is the motion which is accelerated. Okay, hope you understand. Students, let us now discuss about centripetal force. Okay, we have already learned that force is needed to change the direction of motion, or we can say that create velocity or to accelerate a body. Okay, so for a particle to move in a circular path or to remain in a uniform circular motion, there has to be a force because the direction of particle changes at each point of the circle. So the force that is needed to make a particle or a body to remain in its uniform circular motion is called your centripetal force. So students, suppose this is the circular path in which a particle moves, and we have already discussed that it changes its direction at each point of the circle. So that means how it changes. Actually, at each point the motion is tangential. Okay, so it should go in this way. Suppose this is a particle A and it should go in that way. Okay, But what happens at this point when the particle tries to have a tangential motion, a force that acts towards the center of the motion and perpendicular to that particular particle. So this is the centripetal force and it acts at each point of the circle, thereby making this particle move in a circular path. For example, see, it tries to move and suppose this is the point where it should be. But what happens? The direction should be in that direction, see, tangential. But again, the centripetal force, it make the body move in this direction rather in the tangential direction. This happens at each point. That means, suppose it reaches the first quarter, the force acts towards the center. Again, here also the force, it is acted upon toward the center. Each point, not a single point is left. At each point, see, from here it moves like this. See, the force, it acts toward the center. It keeps on happening. That is why it can maintain the uniform circular motion. See, you can clearly see that when we try to go towards a linear direction, but we are forced to move in a circular direction because we are actually forced to move toward the center, and perpendicular force acts towards the center at each point of the circle. That's why it maintains a circular motion. Okay, so this is the force that is called a centripetal force. Centripetal force. Centripetal force acts at each point of the circular path and it is perpendicular to the particle in motion. Okay, and one more thing is that centrifugal force acts towards the center of the circular path. Okay, these two things you need to remember. So centripetal force can be defined as the force acted upon a particle towards the center of the particle and perpendicular to the particle, and it helps the particle to maintain the uniform circular motion. We can have many examples of centripetal force. For example, you might have learned about electrons. The motion of electrons, they move around the nucleus, which is at the center of the atom. Okay, how they move? The electrons are pulled towards the nucleus with the force, that is the centripetal force. And in solar system, a planet moves around the sun because of the gravitational pull that is provided by the sun on that particular planet. That is why that force is also called the centripetal force. In the same manner, moon also moves around the earth because of the gravitational pull that is provided by the earth on the moon. So that is also called your centripetal force. And from these discussions we can also come to a conclusion that in a circular motion the body moves in a circular path with uniform speed and variable velocity, and it is always in its dynamic equilibrium. Okay, hope you understand. Students, let us now discuss about centrifugal force. Centrifugal force is a force which is assumed by the observer which is moving with the body in a circular motion, and it is assumed to be acting away from the center of the circular path. The magnitude of the force remains the same, and as it is assumed that it is acting away from the center of the circular path, so it is in the opposite direction of the centripetal force. Okay, the magnitude of the force is same as the centripetal force. So the overall force acting upon a body remains zero. But you just need to remember that it is not a reaction force. Okay, it is just an assumption, or you can say fictitious force. Okay, so let us now try to understand about the centrifugal force with an experiment. Okay, to begin with the experiment, what we need to do, we need to tie a ball at one end of a string and the other end should be tied to the center of a merry-go-round. And when the merry-go-round starts, then the string which was loose previously now gets a tension T. Okay, tension T, and it rolls the ball towards the edge of the merry-go-round, as you can see in this diagram. Okay, now the ball, it rotates along with the string around and around the merry-go-round. Okay, in that case the ball is observed by two persons. The first person who observes the ball is the person M, as you can see in this diagram, who is standing in the field, and the second person is person A, who is standing in the platform at the center of the merry-go-round, as you can see in this diagram. So what is happening over here? Person M observes that the ball is following a circular path. But what is happening with person A? See, person A, as you can see in this diagram, it observes that the ball is just in front of him. Okay, because the platform is rotating, that means A is also rotating with the platform, and as his position changes from A to A1, A2, A3, he observed that the ball is exactly in front of him at the position P1, P2, P3 and so on. That means he feels as if the ball is at a stationary condition. So there are two observations. First is the observation by the person M standing in the field, and second by the observer or the person that is standing on the platform at the center of the merry-go-round. So let us try to understand this in detail. Okay. So students, for person M, as you can see in this diagram, the ball is following a circular path because the tension T provides the centripetal force which is required for the circular motion. But person A feels as if the ball is stationary. Why is it so? Because he feels two forces acting upon a body. The first force is the tension T of the string, that is toward the center of the merry-go-round, and the other one is centrifugal force that goes away from the center of the merry-go-round. The magnitude of both these forces are equal and they are opposite in direction. So the total force acting upon the body gives us the value 0. And we know that to make a body move or to generate motion, we need certain kind of force. And if there is no force acting upon a body, then the body doesn't move. That means it is at its stationary position. That is the same thing happens when an observer observes the movement of the ball along with him in a circular path. He feels as if the ball is in stationary position. Okay. So students, just try to think. The ball is rotating with the string. Tension is there. And if at any moment the string breaks, what would happen to the ball? And what these persons, the person M and A, would observe. Let us now discuss this case. Okay? Students, suppose the string which is attached to the ball breaks at some time in the circular motion. Suppose as you can see in this diagram, the string breaks at position P. So what happens? The observer who is standing on the field, that is person M, he observes the ball to follow a straight line in the direction of PT. Okay, as you can see in this diagram. But what happens to the observer A, who is standing on the platform at the center of the merry-go-round? He would still observe the ball to be stationary but going radially away from him. What does it mean by radially away? As it is a circular path, so it has a radius. So at position P, AP would be the radius for the circle. And when the string breaks and the ball follows the tangential path, that is the straight line PT from position P to P1, P2, P3, the person at center, it feels that the radius of the circle increases. Just look at me. Okay. Suppose this is the ball and I am the person. It is actually stationary, but when it breaks, it goes away, but still it is in front of me, isn't it? You can feel it. I am doing it again. Suppose I am observer A. Now this is position P and here the string breaks. What will happen now? It follows this direction. Okay? It follows this direction, straight direction, because this is the point at which there would be the tangential motion of the ball. It will follow a straight line. See now what happens? It is moving along with me. I am also moving, but the radius of the circle, it increases, isn't it? See, it is with me, in front of me, but the radius from the center to this ball, now it has increased. So the person feels it is going radially away from it. Okay, hope you understand. These are the two observations. So that is why the person on the rotating frame has to assume the presence of the centrifugal force. Okay. So from these discussions, we can come to a conclusion that the centrifugal force is not a real force. The only force that is acting upon the rotating body is the tension that is toward the center, which is called the centripetal force. And centrifugal force, it does not exist actually, but it is a virtual force or fictitious force which is used to describe a form of motion. Okay, hope you understand. Students, today we have discussed about the centripetal force and centrifugal force. Hope you have understood everything clearly. If not, please watch the video again, go through the book, revise properly. You would understand everything properly. Okay, so you need to revise again and again and practice more and more to have a greater grasp on concepts. So as I always say, keep revising, keep practicing, and most importantly, keep smiling.